Good afternoon, children. In the previous class, we learnt about the types of the renewable energy resources like the solar energy, hydroelectricity, tidal energy, and geothermal energy. Today, we will continue with the renewable resources like the wind energy. Wind, like the sun, is nature's gift to us. It is free and it is widely available. What is wind, children? It is just the horizontal movement of the air that we feel around us. So wind is actually now used to produce electricity also, which the people over are actually using and are now greatly dependent on it. When the wind blows, we have a turbine and three blades, which you can see in the picture also. It turns the three large blades of the windmill, which are attached to a turbine. Now this turbine, which is connected to a generator, converts the energy of the wind into electrical energy. Now I'll be adding a video so that you can understand the technical formation of the electricity through the turbine and the generator. But before that, we need to understand where all these are being used in an extensive manner, and where you have too many windmills in one area. That area is known as a wind farm. And you have these being used for the crushing of grains, lifting water from the wells, and then to even functioning of the heavy machinery. The electricity generated from the wind or the windmill is also used. And countries like China, USA, Germany, and Spain are the leading wind power producing nations in the world.
We've all seen those creaky old windmills on farms, and although they may seem about as low-tech as you can get, those old windmills are the predecessors for new modern wind turbines that generate electricity. The same wind that used to pump water for cattle is now turning giant wind turbines to power cities and homes. Okay, have a look at this wind farm in the California desert. A hot desert next to tall mountains, an ideal place for a lot of wind. Here's another one on the windy prairies of Wyoming. Now, today's wind turbines are much more complicated machines than the old prairie windmills, but the principle is the same. Both capture the wind's energy. Okay, here's how it works. First, a wind turbine blade works sort of like an airplane wing. Blowing air passes around both sides of the blade. The shape of the blade causes the air pressure to be uneven, higher on one side of the blade and lower on the other. And that's what makes it spin. The uneven pressure causes the blades to spin around the center of the turbine. On the top, there's a weather vane that's connected to a computer to keep the turbine turned into the wind so it captures the most energy. Now, the blades are attached to a shaft, which only turns about 18 revolutions a minute. And that's not nearly fast enough to generate electricity by itself. So, the rotor shaft spins a series of gears that increase the rotation up to about 1,800 revolutions per minute. And at that speed, the generator can begin to produce electricity. So, why are wind turbines so tall? Well, the higher up you go, the windier it is. More wind naturally means more electricity. Larger turbines can also capture wind energy more efficiently. The blades can sweep a circle in the sky with a diameter longer than a football field. Now, what's really cool is that even a small wind farm like this one in Wyoming can generate enough electricity to power more than 9,000 homes. And larger farms can provide much more clean energy for our homes and businesses. And it's not just on land that turbines can capture the wind. Our oceans and the Great Lakes provide a reliable and consistent source of wind that we can capture and turn into electricity. The Energy Department is supporting innovative offshore wind projects that will help build some of the first offshore wind turbines in U.S. waters. As the wind energy industry continues to grow, offshore development has the potential to significantly boost domestic renewable energy production, especially in coastal areas. With more than 50% of the U.S. population living within 50 miles of a coastline, capturing wind off America's shores has the potential to provide energy to countless homes and businesses. Wind energy. On land or offshore, a reliable and renewable clean energy source, helping move America toward energy independence.
The last renewable energy resource that we are going to learn is about the biogas. That is the animal waste and all other kinds of organic waste, that is from the farm also. In this diagram, you can see that the animals and the farm waste is called the organic waste, and collectively they termed as the biogas. That is which they produce. The material generated by the household each day are converted into biogas. This gas is an excellent source of cheap power for small unit or a small scale uses like cooking and lightening in the house, or some small unit factory or workplace. But it is not used for an extensive area because the energy produced is very less through the animal waste and through the bio organic waste. Now this biogas is also known as gobar gas or the garbage gas. So you can learn these two new terms also, and and it's also very very beneficial because biogas is a clean, non-polluting and an economical form of producing energy. And the dung, that is the cow dung or any of the animal dung and the vegetable waste, are disposed of in a very useful manner to yield gas, that means to generate the gas for cooking and for heating. This gas is supplied from the plant directly to the source, that is, you can see in this diagram also that the biogas is directly supplying it to the for the cooking or for lighting of the lamps in the houses. And this actually eliminates a lot of problems which are generated while storing the gas, because we don't need to store it, it is being produced and it is directly being used also. So these are the three basic advantages of biogas. Dear children, let us now continue with the non-renewable energy resources. Now, these are resources which, when once used up, they cannot be replaced. And they also bring about a lot of pollution while they are being consumed or used. So these non-renewable energy resources are also known as exhaustible resources. All of this we had discussed in the previous class. Because their supplies are limited, so they are exhaustible resources. And basically the fossil fuels such as the coal, petroleum and natural gas belong to this category. Not only the fossil fuels, but the nuclear energy obtained from the uranium deposit is also a non-renewable resource, because uranium deposits in the world are very limited. Therefore, they will also get over at one point of time after extensive use of it. Let us now understand all the non-renewable resources in detail. The first one is the coal. Let's understand the uses of coal. It is mainly used to generate heat and electricity. It is used in the household and the industries to accomplish various tasks. It is one of the cheapest power resource that we have. The iron and steel industry heavily depend on it. It is also used all the byproducts are also used as the coke, tar and the coal gas. And this fossil fuel is a major fuel which is used in many industries. It is a hard black mineral that is found below the earth's surface, and it is burnt to produce heat. Let's understand the coal formation so that we can understand why it is so important for us. The coal formation began when the plant matter was being buried under layers of sediment millions of years ago. Over a period of time, more than 650 million years ago, due to intense pressure. So you can just mark it in your book also. A, intense pressure of the overlying sediments. Number 2, heat, and the buried vegetable therefore gradually metamorphosed into coal. So here you have three basic factors, that is your heat, pressure and the time. That means around 650 million years, I told all of you. All of the time, heat and pressure actually formed the coal. The coal formed is also of various types because it depends on the content of carbon present in it. Therefore, it is categorized on that format. Here are some precise fo- pointers given to you to understand how coal is formed. You can easily understand from this also, but we have already discussed about the three basic criterias, that is your time, heat, and the pressure applied to all the sedimentary layers which were formed, and the buried vegetation gradually turned into coal. You can read this that the formation of coal takes millions of years, and the plants in the forest basically, when they are decaying, they get decomposed, and the swamp area is formed. As the years passed, they just continue to form a layer on top of each other, and when they are compressed, that means when they are pressurized and heat is also combined along with it, some physical and chemical changes take place, and eventually they turn into carbon rich deposits. Here's another picture explaining that to you, that how coal was actually formed. So here now we have the types of coal, that is peat, lignite, bituminous and anthracite. All these are types only depending or based on the carbon content of the coal which is found. Here I've made a table for you in which you can easily categorize the carbon content. Peat is considered to be the lowest grade or quality of coal which is found because it has only about 20 to 30% of carbon content. Lignite is a better form of it, but it is still a poor quality coal, that is 60% of carbon content is found in it. Bituminous has approximately more than 65 to 70% of carbon content, and it is a higher quality of coal which is found in the earth's crust. Here the last one, that is the anthracite, which is supposed to be the best quality coal, and it has the maximum carbon content. What is the carbon content doing? It is going to make the coal burn for a longer period of time. Therefore, more heat energy will be released from it. The less the carbon content, the lesser time it will ignite itself, and the lesser energy will be released. Therefore, these are the categories and the carbon content of the types of coal. This is some extra information about coal if you want to know, and you can read that during your free time. What's most important for you to learn is that China, USA, India, Australia, and Russia are the major producers of the coal. But and these countries have very large reserves. Here you can see the mine. This mine is in this Navya mines, that is the Tamil Nadu, which is very rich in the lignite quality of coal. So you can see how huge a reserve of coal mines India also has. India's main reserves lie in the Damodar Valley or the Chota Nagpur Plateau area, this area where you have the Damodar River. And some of the major mines which are located at Jharia, Raniganj, Giridih, Bokaro, and Navayali in Tamil Nadu, which is rich in lignite. I've given you a picture of that also.